Switching, which is also called as layer 2 technology. You see, we have switches to connect devices which are in same network, same subnet. We have switches to connect the devices that are in same subnet, same network, same subnet. If you have multiple subnets in your organization, let's say you got 100 computers, out of which 10 computers belong to department 1, another 10 belong to another department. So likewise, you have 10 departments. Now, you don't need to buy 10 switches. You can create virtual switches called VLANs. For each department, you can give a virtual switch, VLAN. Now, our focus is not on VLAN. Our focus is on understanding switching. Very basic, very first topic. Switching is nothing but forwarding the packets based on the MAC address which is found inside the packet. In a data packet in layer 2 frame, we will have a destination MAC address. For example, you see, you got a switch and you got some computers. And this is 10001. Let's say the MAC address is AAA. 10002. Let's say the MAC address of this PC is BBB. 10003. MAC address is CCC. 10004. MAC address is DDD. So we got MAC addresses and IP addresses on each device. And let's say the port name is F01 here, F02 here, F03 here, F0/4. So to this switch, we have 4 devices connected. 4 devices, 4 computers. They're all connected to one common VLAN, one common broadcast domain, which we'll talk about later. Now the switch, when a packet arrives to any of the port, it will not look into the IP address of the packet, it looks into the MAC address. For example, this A is pinging C. A is trying to reach C. What will be the source IP address, destination IP address, source MAC address, destination MAC address? Source IP address will be 10001. And the destination IP address is 10003. Source MAC address is AAA. Destination MAC address is CCC. Let us assume the switch is very fresh, meaning the MAC table in the switch is not up to date. Maybe the switch did not receive any traffic for last 1 hour, or it may be a new switch added. Let's take a scenario where the switch did not receive any communication, any packet for last 1 hour. In that case, the MAC table will be refreshed. It will not have any entries. It will be blank, empty. I told you A is trying to talk to C. When this packet with these details come to the port, let's say F01, immediately switch will update the table with the source MAC address. Understand? It learns that AAA is connected on F01 from this packet that is coming. And then it wants to go to this destination. It looks into the table for the destination CCC. Unfortunately, there is no MAC address CCC in the table. Only if the destination MAC address is not seen. Only when the destination MAC address is not seen, it will flood the traffic. What is flooding the traffic? Sending to all. Sending to all. So the switch will broadcast. The switch will flood because you do not know where CCC is. The packet goes to this guy. As soon as he receives, as soon as B receives, as soon as the destination receives, it will not look into source, it will look into the destination. Is this destination my MAC address? No. Then I should not open this packet. So this guy will drop it. Likewise, this guy will also drop it. But this guy will receive it, will accept it, will open it. Why? Because the destination MAC address is matching with its own local MAC address. So what this PC will do now, if it needs to respond back, it will generate a packet with a source IP address 10.0.0.3, destination IP address 10.0.0.1, source MAC address CCC, destination MAC address AAA, which was our sender earlier. Now the sender is CCC. Please listen. When this packet goes to the switch, to this port, immediately switch learns that I got a new person learned on F03 called CCC. It learns that someone called CCC is connected on F03. Okay. CCC is connected. Now where the packet needs to go? A. Do I know about A? Switch will check, do I know about A? Yes, I know. A is on F01. So it will simply forward the packet to the exact exit port without flooding it. Earlier it was flooding because the destination was unknown, but now the destination is known to this switch. So what it does? Unicast. Now, the main important point that I want to emphasize here is the IP address was not at all used by the switch. To do forwarding decision, It is only the MAC address of the packet decides the exit port. It's only the MAC address decides, not any IP address. That is why we call switches as a layer 2 device. Is that clear? Thank you. Now, we learned one fundamental that when switches do not know about a destination, switches will flood. If the destination is known, it won't flood. Instead, it will send to the right port by looking into the MAC table. It knows which exit interface the destination is connected. Fine. Now what is next? What if the source and destination are in same port? It will drop. Let me give you an example. I have a hub. Okay. Now, when 10005 talks to 10004, the flooding will happen. So not only it goes to 10004, it will also go to the switch because hub will always flood. So switch learns that on F04, I am connected to EEE. When D talks to this E, again the flooding will happen. When D talks to E, the flooding happens. The switch learns that I have another MAC address on same port, which is DDD. Now, if this B talks to EEE, the frame comes to the port learns new MAC address called BBB, and it wants to go to EE. It will check this MAC table. It will send it out via F04. This is simply learning, and it learned the MAC address. It forwarded the packet to the destination. Okay, now what if EE is talking to DDD? The packet comes to the switch with the source MAC address EEE and destination MAC address DDD. When this packet hits the switch port, it checks the destination DDD. DDD is in the same port where the packet is coming, where the source is connected. Both source and destination are in the same port. In this scenario, the switches will not forward. Instead, what it will do? Filter. It will drop. It won't forward anywhere. Because the hub always broadcasts, a copy came to the switch drops it. But another copy went here, it was accepted. So far what I have explained to you is switching means layer 2 forwarding. Based on MAC address, the decisions were made where to forward the packet. And we saw when the MAC address is unknown, switches flood. When a frame comes to a switch, it always checks the source MAC address. If the MAC address is not in the MAC table, it updates the MAC table with a port. And we also learned that when the destination is known, it forwards the packet via the port to which the destination is connected. We also saw when the source and destination are in the same port, they filter. So we have seen the functions of a switch. Number one, it learns the source MAC address. Number two, it floods whenever the destination is unknown. Number three, it forwards if the MAC address is there in the MAC table. Number four, it filters if the source and destination are in same port. Any question on functions of switch? I have this IP address on the first computer, and let me go to the second one. Third one. And fourth one. See, we don't give MAC address. MAC addresses are hard-coded address, which is 48-bit size. I don't give MAC address to any device. It's only the IP address I'm giving. MAC addresses are embedded into the device NIC card. So when device generate any packet from the NIC card, the MAC address will be copied. Now, we have not done any communication between any device, and so far no pinging. You see the switch interfaces are already up. You don't need to say no shutdown. Only on the routers we have to say no shutdown. Okay, before let me show you the MAC table. Show MAC address table. You see, it has already learned one MAC address of the device connected on F04. Let's go and check F04. This one. I'll show you the MAC address of this device. ipconfig all. If you see here, the MAC address is ending with 099D. Go back to the switch. 099D. Correct. Now, when did I generate a traffic? I did not generate any traffic. Then how the MAC address is learned? You see, the PC sent some keep alive packets. The operating system on this computer, they send a tiny message to check the status of the link. With that, it has learned. But from the other PCs, the switch did not receive. The reason is the interface came back and then I gave IP address here. Whereas here, I gave IP address and then the interface came up. So that keep alive packet went. Now, let's try pinging from here to 10.0.0.4. So before I ping, I want to show you the ARP table here. ARP-A. There is no MAC address. When I ping 10.0.0.4, it will discover the MAC address and then ping. Let me show you. It has got the MAC address of the destination. Let's go now to the switch and see how many MAC address it has learned. You see, it has learned the MAC address of the device that is connected on F01 from where we pinged. This one was the destination which was already there. Now let me try pinging from here to here. Ping 10.0.0.3. So I'm expecting so it's a while. For a while we did not touch this PC after pinging. Now let's see whether the MAC table is available. You see, I told you. If you leave for some time, it refreshes. Let's go now back and try pinging again. I'm pinging from this first PC to the last one and also to the second last one and then the second one. Now I'm expecting the MAC table to be updated with all 4 MAC address. You see? It learns the MAC address. Yeah? It learns. It listens to the source address of the incoming frame and learns this MAC address against the port. Okay? That's very important. And I also showed you the MAC table will get refreshed if you don't touch it for, say, 10 minutes. Sometimes some devices are tuned to refresh every 5 minutes. Some device up to 15 minutes, depending on the switch vendor, depending on the series of the switch, all the stuff. The service provider devices, they keep refreshing very fast because they need to connect to many customers. As we have learned the fundamental of a layer 2 switch, we need to go next level. Switches can be virtualized. We can take one physical switch and connect many computers from different department. I'm putting in different color to say they are not of same department. And then we can group them into different virtual switches. What is the benefit? You no need to buy multiple physical switches. If you have one big physical switch with enough port, you can manage with that one switch by creating multiple virtual switches inside that physical switch. We call this as VLAN. And VLANs are identified by a number. Let's say this is VLAN 10, VLAN 20, VLAN 30, VLAN 11. You can create VLANs from 2 to 1005. VLAN number 1 is already created on the switch by default. This particular number 1 VLAN will be always there with all the physical interface mapped to it. And VLAN 221005 is what you can create. In a very high-end switches, you can even create up from 224094 4094 VLANs. But in most of the switches, you will see only up to 1005. 1005, who wants it? 1005 VLANs. Don't worry, you will not need this big number. Then why we have this big number? You can give your own convenient numbers. You need not to give 11, 12, 13, 14. If you see, I've given 10, 20, 30. I've jumped nine numbers in the middle. It's okay because we have enough of VLAN IDs. So now this, even though it's one physical switch, this is as equal as you got 4 physical switch. Why? Because it will never allow communication between these. It will never allow. It is as equal to 4 physical switches. This, we call it as one broadcast domain. Why? When any broadcast is sent, it will go only to these 3 ports, not to this port. When any broadcast is sent, it will only be going to this 3, but not to any other VLAN members. So each VLAN is one broadcast domain. They got one common controller. These 4 ports have got one common controller. Before creating VLANs, all the ports will be a member of this default VLAN, which means all the ports are having one common controller. By creating VLANs, you create multiple controllers, multiple broadcast domain. VLANs are nothing but virtual switch, which is also technically called as multiple broadcast domains. Multiple broadcast domains. By default, how many broadcast domains you will have? Only one. By creating VLANs, you are creating multiple broadcast domains. What is the advantage? Advantage is I can put different departments in different broadcast domains so that the broadcast of the sales department will not impact the HR. The broadcast in the production department will not disturb admin. You are able to provide a layer 2 isolation between the departments. Yep. So we are going to have multiple broadcast domain. As a result, we can have very good control over the data flow. We don't unnecessarily flood. We don't unnecessarily flood the traffics to other departments. Yeah, we localize. Right, many more things, about VLANs we are going to discuss in our next class.